Geographic information systems, often called GIS, are very powerful tools. They help us understand our world in a new way. Think of GIS as smart maps. These maps can do much more than just show you where places are. GIS links information, or data, to specific locations on a map. This means we can see patterns and relationships that were hidden before. It combines geography with data. This combination is what makes GIS so useful for many different tasks. It helps us organize information visually, making complex data easier to grasp and use for making important choices about our surroundings. So, how does GIS actually work its magic? Imagine a map made of many clear layers. Each layer holds different kinds of information about the same geographic area. One layer might show all the roads, another layer could show rivers and lakes. A third layer might display where people live, showing population density. GIS lets us put these layers together. We can choose which layers to look at. This helps us see how different things are connected in a particular place. For example, we can see where roads cross rivers or where many people live near a park. This layered approach is fundamental to understanding spatial relationships. The true power of GIS comes from its ability to analyze this layered information. It is not just about looking at maps. It is about asking questions and getting answers from the data. For instance, we could ask GIS to find the best location for a new school. GIS would look at layers showing where children live, existing school locations, road networks, and safe areas. It would then highlight suitable spots. This ability to analyze geographic data helps people solve complex problems. It allows for deeper insights than traditional data tables or simple maps could ever provide, turning raw data into meaningful knowledge. Ultimately, GIS transforms raw data into actionable insights. Data by itself, like a long list of numbers or addresses, can be hard to understand. GIS takes this data and puts it into a visual context, a map. Suddenly the data tells a story. We can see where things are happening. We can understand why they are happening there. This understanding allows people to make better decisions. Whether it's planning a city, responding to an emergency, or protecting the environment, GIS provides the clear view needed to act effectively and with greater confidence for a better future. Urban planning is one area where GIS has made a very big difference. Cities are complex places with many interconnected systems. Planners need tools to manage this complexity. GIS helps them do this. It allows planners to visualize and analyze various aspects of a city. For example, they can map current land use. They can see where residential areas, commercial zones, and industrial parks are located. This information is crucial for planning future development. It helps ensure that new growth is sustainable and meets the needs of the community, preventing haphazard expansion and promoting organized urban landscapes. GIS is also essential for managing a city's infrastructure. Infrastructure includes all the basic systems that keep a city running. These are things like roads, water pipes, sewer lines, and electricity grids. GIS can store detailed information about all these assets. It knows where every pipe and cable is buried. It knows how old they are and when they were last inspected. City managers can use this information to plan maintenance. They can fix problems before they become big and costly. This proactive approach saves money and reduces disruptions to city life, ensuring services are reliable. Another important role of GIS in urban planning is analyzing population patterns. Cities are constantly changing as people move in and out. GIS can map population density and demographic trends. Planners can see which areas are growing fastest. They can understand the needs of different communities. This helps them decide where to build new schools, hospitals, parks, and other public services. By understanding where people live and what they need, cities can allocate resources more effectively. This ensures that services are accessible to everyone and that the quality of life improves for all residents. Furthermore, GIS plays a vital role in improving transportation systems within cities. Traffic congestion is a major problem in many urban areas. GIS can analyze traffic flow patterns. It can identify bottlenecks and areas with frequent accidents. Planners can use this information to design better road networks. They can optimize public transport routes. They can also plan for bicycle lanes and pedestrian-friendly walkways. The goal is to create transportation systems that are efficient, safe, and environmentally friendly. GIS provides the analytical power to make informed decisions towards achieving these important urban mobility goals for communities. Disaster management is another critical field where GIS provides invaluable support. When disasters strike, whether they are earthquakes, floods, hurricanes, or wildfires, quick and effective response is essential. GIS helps emergency managers at every stage, before, during, and after a disaster. Before a disaster, GIS can be used for risk assessment. It can map areas that are most vulnerable to specific hazards. For example, it can show coastal areas prone to storm surges or regions with high wildfire risk. This information helps communities prepare and develop mitigation strategies, potentially saving lives and property before an event occurs. During a disaster, GIS becomes a crucial tool for situational awareness. Emergency responders need to know what is happening, where it is happening, and what resources are available. GIS can display real-time information on a map. This might include the path of a hurricane, the extent of flooding, or the location of active fires. It can also show the locations of emergency shelters, hospitals, and available response teams. This clear visual information helps commanders make quick decisions about where to send help. It improves coordination among different agencies, ensuring a more efficient and targeted response to the unfolding crisis. After a disaster is passed, GIS is used extensively for damage assessment and recovery efforts. Field teams can use mobile GIS applications to collect data about damaged buildings and infrastructure. This information is instantly mapped and shared. This helps authorities understand the scale of the disaster quickly. It allows them to prioritize areas that need the most urgent assistance. GIS can also help manage the distribution of aid, such as food, water, and medical supplies. It ensures that resources reach the affected populations efficiently. This systematic approach speeds up the recovery process and helps communities rebuild. Moreover, GIS helps in planning evacuation routes and managing shelters. Before an anticipated event, such as a hurricane, GIS can identify the safest and most efficient routes for people to leave a threatened area. It can also map the locations of public shelters and their capacities. During an evacuation, real-time traffic information can be integrated into GIS to guide people away from congested roads. This careful planning and real-time management can significantly reduce chaos and ensure that more people reach safety in a timely manner. The ability to visualize and analyze these complex logistics is a key strength of GIS in protecting lives. Environmental conservation greatly benefits from the power of GIS. Our planet faces many challenges such as deforestation, climate change, pollution, and loss of biodiversity. GIS provides essential tools for monitoring and understanding these complex environmental issues. Scientists and conservationists use GIS to map and analyze environmental data. For example, satellite imagery can be integrated into GIS to track changes in forest cover over time. This helps identify areas where deforestation is happening rapidly. Understanding these patterns is the first step towards taking effective action to protect our natural resources and ecosystems. GIS plays a significant role in wildlife conservation. Researchers can use GIS to map animal habitats and track migration patterns. They can combine this information with data on human activities, such as farming or urban development, to identify areas where wildlife is threatened. This helps in designing protected areas and wildlife corridors that allow animals to move safely between habitats. For endangered species, GIS can help monitor population numbers and distribution. This detailed spatial information is crucial for developing targeted conservation strategies. It ensures that limited resources are used in the most effective way to protect vulnerable species from extinction. Managing water resources is another area where GIS is indispensable. GIS can map watersheds, rivers, and groundwater aquifers. It can be used to monitor water quality and quantity. For example, GIS can help identify sources of pollution in a river system by mapping industrial discharge points or agricultural runoff areas. It can also model the impact of climate change on water availability. This information is vital for sustainable water management. It helps authorities make informed decisions about water allocation, pollution control, and conservation measures, ensuring that this precious resource is available for future generations. Furthermore, GIS is used to combat pollution and manage waste. It can map the locations of pollution sources such as factories or landfill sites. It can model how pollutants spread through the air, water, or soil. This helps environmental agencies to identify areas at risk and to enforce environmental regulations. GIS can also assist in planning the optimal locations for waste disposal and recycling facilities. By considering factors like proximity to residential areas, transportation routes, and environmental sensitivity, GIS helps in making these decisions more sustainable. This contributes to cleaner and healthier environments for everyone living in those areas. Section 5. Real-World GIS Revitalizing Urban Spaces with Smart Maps. A compelling real-world example of GIS transforming urban planning can be seen in many cities focusing on smart growth. Consider the city of Portland, Oregon, in the United States. Portland has long been recognized for its innovative urban planning strategies, with GIS playing a central role. The city uses GIS extensively to manage its urban growth boundary. This boundary is a legal line drawn around the city to limit urban sprawl and protect surrounding farmland and natural areas. GIS helps planners monitor development activities near this boundary. It ensures that new construction occurs within the designated urban area, promoting denser, more walkable communities. Portland's Metro Regional Government uses GIS for comprehensive transportation planning. They analyze population data, employment centers, and existing transit networks using GIS. This allows them to identify areas underserved by public transportation. They can then plan new light rail lines or bus routes more effectively. GIS models help them predict how these new services will impact traffic congestion and accessibility. For example, they can simulate travel times and rider numbers for proposed routes. This data-driven approach ensures that public investments in transportation infrastructure are well placed and serve the community's needs efficiently, leading to a more connected and sustainable city. Another key application of GIS in Portland is in the development of green infrastructure. The city uses GIS to map parks, greenways, tree canopy, and natural areas. This information is used to identify opportunities for creating new green spaces or connecting existing ones. For instance, GIS can help pinpoint vacant lots suitable for small community parks or identify corridors for new bike paths along rivers. These efforts enhance the quality of life for residents. They also provide important ecological benefits such as managing stormwater runoff and improving air quality. GIS helps balance urban development with environmental preservation in a very practical way. Furthermore, Portland utilizes GIS for equitable development. Planners use GIS to analyze demographic data alongside data on access to services, housing affordability, and environmental hazards. This helps them identify neighborhoods that may be facing disadvantages. For example, they can map areas with a high concentration of low-income households and poor access to grocery stores or healthcare facilities. This understanding allows the city to target investments and policies to address these inequities. By using GIS, Portland strives to create a more just and livable city for all its residents, ensuring that development benefits everyone, not just a select few. Section 6. Real-World GIS. Responding to nature's fury with data. The response to Hurricane Katrina in 2005 provides a stark real-world example of GIS's critical role in disaster management, highlighting both its capabilities and the challenges of its implementation during extreme events. Before the hurricane made landfall, the National Hurricane Center used GIS to track the storm's path and predict its intensity. This information was crucial for issuing warnings and initiating evacuations. GIS maps showed areas most vulnerable to storm surge and flooding, based on elevation data and proximity to the coast. These maps helped officials understand the potential scale of the disaster, though the actual impact was devastatingly large. During and immediately after Hurricane Katrina struck, GIS became indispensable for emergency responders. With widespread power outages and communication failures, getting accurate information was incredibly difficult. Responders used GIS to map flooded areas using satellite and aerial imagery. They mapped blocked roads, damaged infrastructure, and the locations of stranded people. Mobile GIS units allowed teams in the field to collect data and send it back to command centers. This real-time mapping helped coordinate search and rescue operations. It enabled the U.S. Coast Guard and other agencies to direct helicopters and boats to people in urgent need of help, saving many lives in chaotic conditions. In the aftermath of Hurricane Katrina, GIS played a vital role in damage assessment and long-term recovery. The Federal Emergency Management Agency, FEMA, and other organizations used GIS extensively to map the extent of damage to homes, businesses, and public infrastructure. This involved analyzing high-resolution imagery and data collected by field assessment teams. GIS databases stored information on property ownership, insurance claims, and the distribution of aid. This systematic approach helped manage the enormous task of debris removal, infrastructure repair, and housing assistance. It provided a clear picture of the devastation, which was essential for planning the rebuilding efforts. The lessons learned from Hurricane Katrina also spurred advancements in the use of GIS for disaster management. There was a greater recognition of the need for better data sharing and interoperability between different agencies. Efforts were made to improve pre-disaster data collection, such as creating more accurate elevation models for vulnerable coastal areas. The event underscored the importance of having robust GIS capabilities at all levels of government. Today, GIS is an even more integral part of disaster preparedness and response, with improved tools and protocols helping communities better withstand and recover from nature's fury, ensuring more coordinated efforts. Section 7: Real-World GIS Conserving Wildlife Habitats Through Mapping. The conservation of the mountain gorilla in Central Africa is a powerful real-world example of how GIS aids environmental protection efforts. Mountain gorillas are critically endangered, living in volcanic mountain ranges across Rwanda, Uganda, and the Democratic Republic of Congo. Conservation organizations like the Dian Fossey Gorilla Fund and the International Gorilla Conservation Program use GIS extensively. They map the gorilla's habitat, which includes dense forests. GIS helps them understand the exact boundaries of this habitat and monitor any changes, such as encroachment from agriculture or illegal logging, which threaten the gorilla's survival. Ranger patrols are essential for protecting gorillas from poaching and other threats. GIS is used to plan patrol routes and monitor their effectiveness. Rangers often carry GPS-enabled devices to record their movements and any signs of illegal activity they encounter, such as snares or poacher camps. This data is then uploaded into a GIS database. Analysts can map the patrol coverage and identify areas that are not being adequately monitored. They can also map hotspots of illegal activity. This information allows park managers to deploy rangers more strategically, maximizing their impact and improving the safety of the gorilla populations within the parks. GIS also plays a crucial role in monitoring the health and behavior of the gorilla groups themselves. Researchers use GPS to track the locations of different gorilla families. They collect data on group size, births, deaths, and movements. This information is entered into a GIS, allowing scientists to analyze how gorillas use their habitat and how they interact with each other. For example, GIS can show how different groups utilize specific food resources or avoid areas with high human activity. This detailed understanding of gorilla ecology is vital for making informed conservation decisions, such as where to focus habitat restoration efforts or how to manage tourism responsibly. Furthermore, GIS helps in engaging local communities in conservation. Maps created using GIS can be powerful tools for communication and education. They can show local communities the importance of the gorilla habitat, not just for the animals but also for ecosystem services like clean water. GIS can also be used to plan community development projects that provide alternative livelihoods, reducing reliance on activities that harm the forest. By involving local people and showing them the benefits of conservation through clear visual aids, GIS helps build support for long-term protection of the mountain gorillas and their fragile environment, ensuring a future for these magnificent creatures. Section 8: The Power of Seeing: How GIS Transforms Decisions. The transformative power of GIS in decision-making lies in its unique ability to make complex information visual and geographically relevant. Humans are visual creatures. We understand patterns and relationships much more easily when we can see them on a map. GIS takes spreadsheets full of numbers or databases of records and turns them into interactive visual displays. This simple act of placing data in its spatial context can unlock profound insights. For example, seeing crime statistics mapped by neighborhood immediately highlights hotspots, which is far more impactful than just looking at a table of addresses and offense types for law enforcement. GIS empowers decision-makers by providing a common operational picture. When different departments or agencies are working on a problem, they often have their own data sets and perspectives. GIS can integrate these various data sources onto a single map-based platform. This creates a shared understanding of the situation. Whether it's city planners, emergency responders, or environmental scientists, everyone can look at the same map and see the same information. This facilitates better communication and collaboration. It helps break down silos between organizations, leading to more coordinated and effective actions, ensuring everyone is on the same page. Moreover, GIS enables what-if scenario planning. Because GIS can model relationships between different geographic features and data, users can explore the potential consequences of different decisions before they are made. For instance, an urban planner could use GIS to model the impact of a new highway on traffic patterns, air quality, and property values in surrounding areas. They could try different route options and see the projected outcomes. This ability to simulate and compare alternatives helps decision-makers choose the best course of action. It reduces risks and helps optimize the use of resources, leading to more robust and well-thought-out plans. Ultimately, GIS fosters data-driven decision-making. Instead of relying on intuition or incomplete information, decision-makers can use GIS to analyze evidence and base their choices on facts. The visual and analytical capabilities of GIS make complex data accessible and understandable to a wider audience, not just technical experts. This transparency can also lead to greater public trust and engagement in decision-making processes. By clearly showing why certain decisions are being made supported by geographic evidence, GIS helps build consensus and ensures that choices are more informed, equitable, and effective for the communities they impact positively. Section 9, GIS Tomorrow. Innovations and Future Pathways in Geographic Insight. The future of GIS is incredibly bright, with ongoing innovations promising to make it even more powerful and accessible. One major trend is the integration of GIS with artificial intelligence, AI, and machine learning, ML. AI algorithms can analyze vast amounts of geographic data, including satellite imagery and sensor feeds, to automatically detect patterns, make predictions, and even automate mapping tasks. For example, AI could identify early signs of crop disease from drone imagery or predict urban growth patterns with greater accuracy. This will allow GIS to provide even deeper insights and more proactive solutions to complex global challenges for us. Another key development is the rise of real-time GIS. With the proliferation of sensors, GPS-enabled devices, and the Internet of Things, IoT, geographic data is being generated at an unprecedented rate. Future GIS platforms will be better equipped to ingest, process, and visualize this streaming data in real time. This has huge implications for applications like smart city management, where traffic flow, public transit, and utility services can be monitored and optimized dynamically. It will also enhance disaster response, providing an up-to-the-second view of evolving situations, allowing for quicker and more adaptive actions by response teams on the ground. The move towards cloud-based GIS and web GIS is also transforming how geographic information is used and shared. Cloud platforms make powerful GIS tools and vast data sets accessible to anyone with an internet connection, often through simple web browsers or mobile apps. This democratizes GIS, empowering smaller organizations, community groups, and even individual citizens to leverage geographic insights. Collaborative mapping projects and crowdsourced data initiatives will become more common. This will lead to richer, more diverse geographic information that reflects local knowledge and a wider range of perspectives for community projects. Looking ahead, GIS will continue to be essential for addressing our world's most pressing issues, from climate change and sustainable development to public health and global security. As the technology evolves, its ability to transform data into actionable knowledge will only grow stronger. The integration of 3D and even 4D time-based visualizations will offer more immersive and intuitive ways to understand our complex world. The future of GIS is about providing deeper geographic understanding to more people, enabling smarter decisions, and fostering a more sustainable and equitable future for all inhabitants of our planet. GIS will be a key tool for the next generation of problem solvers.